What's the likelihood function of observing those 6 data points about people getting discounts and choosing to buy burgers or not? The likelihood function is just the joint probability density evaluated at each data point. For the first person, they got a discount of 0, so their x value is 0, and they chose not to buy it. We evaluate the density function here. Another person decides not to buy it, they got a discount of 20. This person bought it, they got a discount of 40. This person bought it again, they got a discount of 60. It'll be 6 terms here. We're going to use the log likelihood trick again. You take the log of the product of a bunch of things. That just becomes the sum of the logs of those things. We use the Logit equation that you derived, that the probability of success, given their x value, their discount, is the exponential function of this linear combination of predictors. In this case, there's an intercept, and there's beta 1 times our discount rate. By the way, beta 0 and beta 1 are the parameters of the model. We're maximizing the log likelihood subject to our choice of beta 0 and beta 1. And those have hats on them. We're going to make estimates of beta 0 and beta 1 to maximize the log likelihood function. The probability of success and then the probability of not buying the burger is just 1 minus this, which if you simplify it, is just 1 divided by 1 plus e to the beta 0 plus beta 1x. Now I just make this substitution, plug in this every time we got a success here, and this every time we didn't get a success, and then I also plugged in what their discount rate was. If you got 100% off, put that here, 20%, 40% here, I could just drop the term because they got 0% off. So this is the log likelihood function. And this is as far as we'll go by hand because with 6 data points, it gets a little gnarly. Next, I'm going to go to R, write this log likelihood function, and then I'll show you how we can beta 0 and beta 1 in order to maximize this log likelihood function. So here's my log likelihood function. I wrote a function that takes parameters, beta 0 and beta 1. I'm expecting that params is a vector of length 2. And the first element will be beta 0, and the second element will be beta 1. And then I just put in what I wrote previously with all that math, just turned into code. I'm going to run Command Enter. And now you can see LL is a function in my global environment. To test that our function works, we can run log likelihood on the vector 1, 2. So what's the likelihood of seeing a beta 0 that's 1 and a beta 1 that's 2? We can run this piece of code. We get negative 203.3133. Basically always get large negative values for log likelihoods because the log of even odds, so 50-50, is 0. So if the likelihood is anything less than 50-50, it's going to be large and negative. Really, you want to compare the log likelihoods of different beta 0 and beta 1s. This number by itself doesn't have a ton of meaning, but you can see, let's try 2, 2. That has a log likelihood of negative 206. Having a smaller beta 0 is more likely than having a larger one, at least comparing these two things.